Alright, so today we're gonna be talking about different measures of dispersion. Okay, different measures of dispersion. So that would include stuff like the range, interquartile range, semi-interquartile range, and so forth. And then after something else that we'll talk about too is something called standard deviation. So let you guys take this down, and then after we'll start rolling on this. So this is the first component that we're gonna look at today. So with this here, one of the last things I had y'all doing on the assignment was involving cumulative frequency charts. Okay, that's very important because this is something that we have to use in this topic today as well. So it'll be a good opportunity for you to, get a little flashback on what we did and to see how you could use it to apply different stuff. Okay, so what we'd like to see you guys after this, going through the week, take the time out to make sure you go through some stuff that we already did and just review it, just to make sure you got it sharp and so forth. Because once we come to the end of this topic, I'll be sending y'all past papers related to this topic to work on and try to complete, so you could see where you're at and what you need to do to improve and get ready to get that grade 1 that we're trying to get. All right, so the measures of dispersion, right? So the first one is the range. So what is the range? The range is when we find the highest value and take it away with lowest value. Okay, what that represents is the biggest difference that you would find between any two values in a set of data. Okay, so if you take away the highest minus lowest, that's going to be the biggest difference that you're going to find with any two values. That's what we call the range. Now, interquartile range. Interquartile range. What comes to mind when you hear quartile?
A quarter.
A quarter. Excellent. That's what you think of, a quarter. Now, the word inter. We heard of inter-house competitions, inter-school competitions, or whatever the case is. What do you think that means? Not exactly, but it's close in the sense of it's what's among, and in this case, among the quartiles. So we're looking at the range among the quartiles, okay? So that's the interquartile range. So that would be the upper quartile minus the lower quartile. So the upper quartile is basically the value 3/4 of the way of a set of data, right? So think of the upper quartile as basically, like if you think of having 4 quarters, if you have a first quarter, that's 25 cents. You put a next quarter, you get 50 cents. What would you get when you put a third quarter? 75 cents. That's correct. We'll get 75 cents. So then after we put on the last quarter, we get a full dollar, right? So when we talk about upper quartile, we're looking at that section that's kind of like 75% mark, the 75% mark of a data set when we have it from lowest to highest. And the lower quartile, what do you think the lower quartile would be?
25%.
The first 25%, right? So like the first quarter would refer to the lower quartile. All right. So when we take two of those now and subtract them from each other, that is when we get the interquartile range. So I'll let y'all take this down, and then we'll talk about the semi-interquartile range. All right, so the next one, semi-interquartile range. What do you think semi-interquartile range is? We just talked about the interquartile range. Thinking about that word semi, what do you think the interquartile range, the semi-interquartile range would represent?
Like the middle, medium.
So that is basically half of the interquartile range, right? So it almost like in a sense would be like how we look at the median. It's like the middle part of the interquartile range. All right, so that's the semi-interquartile range. So we basically finding the interquartile range and dividing it by 2. Same thing like music, you got a semi-breve. So obviously if you have a semi-breve, you have a breve, right? And likewise, you have a semicircle, you must have a full circle. So a semicircle is half of a circle. So the semi-interquartile range is half of the interquartile range. All right, everybody got us done now? Almost okay. So this one is one that we do not have to know how to calculate, but we have to know how to interpret it according to the syllabus. So the syllabus does not expect us to know how to calculate it, which is quite a journey actually to calculate this. It's a quite better number of steps to do this, which you would usually do in like additional maths or applied maths in sixth form. But this here is something that we just need to understand what it shows, right? So standard deviation is basically the measure of how spread out the data is in relation to the mean. All right. So when you compare the two standard deviations, it basically is saying that the standard deviation that is lower relative to the next, that one basically has data that falls closer to the mean. So think of a lower standard deviation as someone who is shy and kind of close to their mom or dad. And in this case, the mom or dad would be like the mean, right? So all the data would be like all the kids just close to their mom or dad because the standard deviation is low relative to the next one. So if you have a higher standard deviation, that means they're kind of further away from the mean. So it's kind of like they're not so shy, so they're kind of away from the parents compared to the others. So I have a class. Say my first class, I'm going to call it class A. And then the next one is going to be class G. So class A, the average or the mean was 80%. Now, let's say the standard deviation is 10% here. And for this one, the mean is 70. But the standard deviation is 15%. Now, when I look at these two values, the standard deviations, one has 10 and one has 15. So, who has the lower standard deviation? Which class has the lower standard deviation?
Class A.
Class A. Excellent. Class A. So class A had the lower one. And the highest one is class
G.
G. Excellent. So what this means is that when I look at class A, the data for class A was not spread out as class G. So in other words, if I'm thinking of 10 being the smaller number, it's like this class, its grades closer to mean, or it's like this class a little bit more shy relative to the mean. So that means they're kind of closer together. That's why the 10% so small. Whereas in this case now, this 15% is bigger than this one. So this one spread out a little bit more. Okay, so this smaller, this is bigger. The data here is spread out tighter than this one. This one is spread out more than this one. Does that make sense?
Yeah.
Good. So if we had to picture it, this class data would say look something like this, whereas this one would be a little bit more spread out. Okay. All right. So you don't require this. You don't have to necessarily draw this. So you could just keep up to this part here. You just have to keep this part here. So you guys got the first 2 points?
Not yet.
Okay. So those first 2 points are the most important points. So if you look at this diagram at the bottom right, one has a standard deviation of 0.5, one has a standard deviation of 1, the next one has a standard deviation of 2. Who has the largest standard deviation here? 2, right. So the data for 2 is spread out. You see how it's spread out compared to the 0.5? Number 2, the one with 2 is bigger in terms of spread out, like spread out that way, compared to 0.5, which is really thin. You know, this one is bigger. Does that make sense? All right, y'all got it done now? Okay, so let's look at these numbers now. So we have these numbers here. collected from a questionnaire. So 1, 2, 8, 4, 7, and 3. So I want y'all to take down those numbers 1, 2, 8, 4, 7, and 3. The first thing I want you to do is find the range of the data. What is the range of the data? So what did we say the range is? What is the range? Excellent. The highest number minus the lowest number. So what I want you to do is to look at this data, and it's talking about the time spent. So I want you to find the range for this data. So how you worked out? You looked at this 7 here and say the answer is 7. What did you do? Nice. So we look at the highest number, which is 8, and the lowest value, which is 1, and when we subtract, we get 7. Excellent. Okay, so now upper quartile, I'm gonna show y'all how to do upper quartile. I'll show you a little trick that I use to do the upper quartile. All right, so the first thing we have to do, right, we have to organize this from lowest to highest. That's the first thing we have to do. Anytime we're doing a median, quarters, we have to arrange from lowest to highest. So the first number I would have is 1, then 2, 3, 4, 7, 8. So do I have it in order of lowest to highest? Now what I'm gonna do now is I'm gonna pretend like I was finding the median. So what I would do is I would take this, put a split here. You see that? So here is where the median would be, dead center. Remember we was doing this some time back? It would be the two numbers here in the center. Okay, now I have these lines outside here which I look at. So these outer lines basically just kind of makes this like it's a house. All right, so let's just pretend like this here is a house. Okay, so the median is here and the house close off here, right? Oh, the house divided, because this part here is the median. Y'all following me? This is like the middle of the house. Make sense?
Yes.
Okay, good. Now, when I'm looking up here now, in this half of the house, so the upper half of the house, who is in the center? The 7. So 7 is in the center. So I'm going to call this 7 the upper quartile. Y'all follow me? So when I look at that, I haven't crossed any numbers here. So because I haven't crossed any numbers here, I'm saying that it has 3 on this side and 3 on that side. Okay, so this upper quartile is represented by 7. Okay, so the upper quartile is equal to 7. Now on this side here now, I'm looking at the next half. So who is in the middle of this half here now? 2. So when I cross this now, I know that 2 now is my lower. Excellent. So lower quartile. Now I have my upper quartile and I have my lower quartile. Okay, so we got this. And now what do you think we're gonna do next? The interquartile range. Okay, so interquartile range. How do we calculate the interquartile range now?
By subtracting
Subtracting what?
the upper quartile from the lower.
Lovely. So upper quartile minus the lower quartile. So in essence, that would be 7 minus 2, which is 5. So let's say the unit was minutes, so we would say 5 minutes. Now the question is, we also had something else called the semi, and I'll put for short, interquartile range. How do we work this one out? All right, so the upper quartile minus the lower quartile divided by 2. So we worked this one out already, upper quartile minus lower quartile, which was 5. So we are saying that basically our semi-quartile is going to be 5 divided by 2. So then we're going to get 2.5 minutes as our semi-interquartile range. Does that make sense? Y'all follow? All right, good. So I'll give you another example so you could see how it works in another scenario. So this time we're going to use when we have, instead of even numbers, we have odd numbers. So here we have an odd number of numbers. Now, the first thing I have to do is arrange from lowest to highest. So the first number I'm going to have is 15. Okay. Then 20 and 35, 40, 50, 60, and then 65, sorry. All right. So almost pretending like we drawing the house now. Okay, so where would the middle number land? 40. Good. So we cross 40. So now remember 40 is on the line. Okay, so if we was to picture this as a house, 40 is part of the wall. 40 is part of the wall. So we cannot look at 40 as part of any side. 40 is dead center. Alright. So the only numbers we're looking at would be these three here. So based on this, who would be our 60, which would represent the what? Upper quartile. Nice. On this side, 20, which represents what? Lower quartile. All right. So based on this information here, I want y'all to calculate these here. So the range first. After the range, I want you to figure out the interquartile range. And after you do that, you'll do the semi-interquartile range. So what we're doing it for is ungrouped data. So use this data to figure out these things. Y'all doing good, man. Y'all following. All right, so what's the range? How you work that out? Yes, so 65 minus 15, because that is the highest number minus the lowest number. So 65 minus 15 is 50. So this case, $50, right? Don't forget your units, guys. Units very important. All right, what about the interquartile range? How we get at? Excellent. So 60 minus 20, which is $40. So that represents $40, which would be the upper quartile minus the lower quartile. And the semi-interquartile range. Semi-interquartile range would be what? 20. How we get that?
We don't have the answer. It's a quartile range, so you just divide that by 2.
Excellent. So we could say 40 divided by 2, because the interquartile range is 40. So half of our semi-interquartile range should be half of 40, which is $20. That was easy, right? Lovely. Good, good. All right. All right, so I give y'all one to try. I want y'all to take this information. Make sure you write all the numbers properly. Find the lower quartile as well as the upper quartile, the range, everybody. You know what we're doing. So all these numbers here. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now this is going to put you in a very interesting spot. All right. In in this case, you're going to end up with half of the house, and half of that house, you might end up with 2 people in the middle. So if you have 2 people in the middle, what do you think you would have to do? Exactly. So we still do that to find a lower quartile, just like how we would have do it for the median. Just to give you all a little exposure of what could happen here. So for instance, we have 8 numbers here from lowest to highest, right? So my middle would have kind of been here. This is my middle. So that means I ain't crossed no number this time, okay? So I got a house here now. On the first half of the house, who's in the middle? 4 and 8. So these 2 here in the middle. So that means that is where my lower quartile is. So how do I work that out? I have to say 4 plus 8 divided by 2, which gives me 4 and 8 is 12, divided by 2, which is 6. So what's in the middle here now, in this one here? 18 and 19. So in this case, 18 and 19 would be my upper quartile. So I would add them together, 18 plus 19 divided by 2, which is 37 divided by 2, which gives me 18.5. Make sense what I did there?
Yes.
So in this one here, it just so happened that the number that landed in the middle was a full number. So that is why in this case, we had a full number as 20, you see? But in this case, which is why I give you all that question intentionally to give you the hardest potential one that you could get, it would be a case like that where you have to split the 2 in the middle to find the middle, you know, just like how we do median. But instead of doing a median for all the numbers, we're doing it for one half and then the next half. That's why we call them quarters. Does that make sense? Everybody understand now? All right, good. Good.
I have submitted you before.
So y'all try it and then we could go through it if you want. Y'all got it now? All right, so let's go through it. All right, so the center is right here. And then we know we have our houses here, the end of the house here. So based off of this, we have the center here. So if I needed to find a median, I would add these 2 and divide by 2. Okay? If I was trying to find a median, right? I'm not trying to find a median right now, right? So we'll just look at it as this is one half and this is one half. Now we need to find the quartiles. So where would the center be for these numbers over here? The 2 13s, right? So right here would be for this one, which is a lower quartile. So these 2 here, okay? So to work that out, I would have to say 13 plus 13 divided by 2, which is 26, divided by 2 is equal to 13. So 13 represents my lower quartile. Then in this here, where's the center on this half? Between 18 and 20. So that would represent my upper quartile. So then I'll have here now 18 plus 20 divided by 2, which is essentially going to be 38 divided by 2, which gives us 19. So my upper quartile is 19 and my lower quartile is 13. Does that make sense? So my interquartile range is going to be 19 minus 13, which is 6. Okay? Now the semi-interquartile range. Once we have the interquartile range, it's easy to get the semi-interquartile. So what we would have to do here, 6 divided by 2, which gives us 3. And that's it. Y'all follow? Nice. So you could take this down if you didn't have it. Then we go to the next one. This here is for ungrouped data. This is how we find it for ungrouped data. The next thing we're going to look at is how we find it for grouped data. And that's where our cumulative frequency graphs come in. All right, so quick review of the standard deviation, right? So if you look at this here, we have some girls and boys in class, 78% and 72%, right? Now, because we're looking at a standard deviation, we're not worried about the means necessarily. Okay, so if the boys' standard deviation is 15 and the girls had a standard deviation on 20, what we could say is that the boys has a lower standard deviation than the girls. Okay, why does the boys have a lower standard deviation than the girls? Because it has 15% compared to 20%. So what does that mean? What that means basically is that the boys, their data is closer to their mean than that of the girls. That's all it means. Okay, so basically when you see questions asking you about commenting on the standard deviation, that is what you need to do. You basically just need to say, oh well, this one is lower than that one, so that means that the data for the lower one is closer than to its mean than the one with the higher standard deviation. And that's it. All right, so how to do this using cumulative frequency chart. So we have to build a cumulative frequency chart. So just a refresher on cumulative frequency charts. What are cumulative frequency charts plotted on? Lower boundaries, upper boundaries, midpoints, limits. What do we plot them on? Upper boundaries. Excellent. So we plot cumulative frequency charts on upper boundaries. Okay, so first of all, we need to figure out what the cumulative frequency is. So when we start off with this one here, what number would come here? 2. Excellent. 2 would come there. Kaelan, what would be the next number? So if this is 2, what would be the next number? 7. Wonderful. 7. All right. Now, Josiah, we had 2 here, then we had 7 here. Okay, 2, then 7. What would be next? So if 2 is here, 7 is here, what's next? 15. How you get 15? 7 plus 8, which is 15. Justin, what would be next? 18. Wonderful. All right, so we have this now. So the next thing we need to identify is what? What do we have to identify now for this data in order to plot it? The boundaries. Excellent. The boundaries. So the first boundary I want to look at is 9.5, which is obviously the lower boundary here. But when we are plotting that lower boundary from last time, we know that has to match with 0, because that's where we start in. Now the upper boundary for this next one is going to be what? What's the upper boundary for 10 to 14? 14.5. Excellent. What's next? 19.5. Lovely. And what's after that? 24.5. Then what? All right, 29.5. Now this is the trick. From last time, remember the 9.5 goes to what number we said? 0, right? Because no number was there before this category. All right, this class interval. All right, so 9.5 goes to 0. Who does 14.5 go to? 2. Who does 19.5 go to? Who does 24.5 go to? 15. Excellent. 29.5 goes to who?
18.
Excellent. So then we would end up with this table looking like this. And what we will do after we do that is plot the graph. So that's what happens when we sketch a cumulative frequency chart. So basically this is what we did from last time. All right, y'all follow this? You remember this? All right, so quick summary. Who remembers how we identify the median using this?
Cumulative frequency divided by 2.
Nice. So 18 divided by 2 in this case gives us what?
9.
So what do we do with that 9? What do we do with that 9 now? What do we do with that information?
You find it on the y-axis and you draw a line across the graph.
Excellent. All right, so this is what we do right here. We draw it straight across the line, then we go down, and then we try to figure out what that number there is. So here is 19.5. I'm looking at this. This goes in five. So 1, 2, 3, 4, 5. So we have 5 lines. 19.5, 24.5. What is the difference between those two? 5. And we have 5 lines. So 5 divided by 5 is 1. That means each of these lines represent 1. So therefore 19.5, this here would be 20.5, 21.5, 22.5, 23.5, and 24.5. So I know that my median is 20.5. Does that make sense? Y'all remember?
Yeah.
Lovely. Now let's talk about upper and lower quartiles. Okay? So if we had to do the lower quartile, we said that we had this going up to 9. Based on what we was doing earlier, if the first half goes up to 9, where you think the lower quartile would be? What would give us the lower quartile? What number we would be looking at? Close. Yeah, it was close, but remember, say that again. 4.5. Now explain to us why 4.5.
Yeah, because you have to divide it by 4.
Do that, yes. So in the case of going up to 9, we just say 9 divided by 2, is 4.5. So now all I need to do with that information is pretend that I find in the middle of these two here. So the middle of these two from 0 to 9 is 4.5. So I just look for 4.5. So 4.5 is here. So I have 0, 1, 2, 3, 4. And this is the middle of 4 and 5, which is 4.5. Does that make sense? Then what do I do next? What do I do next? Yes. So I put the line down. And then now I try to figure out what this line is telling me. So this is 4.5. This is 15.5. This is 16.5. So here must be 17 because it's in the middle of 16.5 and 17.5. So the lower quartile is 17 minutes. All right. Now, I need to figure out what is the middle of 9 and 18. If you had to do a middle or a midpoint of 9 to 18, why am I using 18? Because that is the highest number that we have, right? So we're going up to 18. So what is the middle number of 9 and 18? The middle of 9 and 18. 13.5. So if I add 9 plus 18, I'll get 27. Then I find half of that, 13.5. So I look for 13.5 now on a graph, mark it across. Okay, so right here is 13.5. So 10, 11, 12, 13.5. Okay, and then I just draw down. So when I draw down now, this number over here is 23.5. So basically, guys, all I was doing was splitting things just like how we were splitting them earlier, right? So the cap was up here was 18. So I find the middle. We know where the median is. Then I found the middle from 0 to that median line here, which is 4.5. 4.5 is the middle of 0 and 9. The middle of 9 and 18 is 13.5. So I look for 13.5, come across here, and come straight down. Okay? Y'all follow that?
Yeah.
All right. So what I want y'all to do is subtract the upper quartile from the lower quartile. So what we're doing here is for group data. Find what the interquartile range would be and then what the semi-interquartile range would be. But what I want y'all to do as well is sketch this. Go through the process. Try to understand what we were doing. If you're not sure, ask some questions. Let's go through it so you guys can make sure you understand this. Because the next one I want y'all to do on your own.
And the cumulative frequency, you go after 20, you have to find the half of 20 and just like try to learn.
Very good question. Remember, right? If we back up, let's back up here, right? When we look at our cumulative frequency, what was the value that we went up to?
29. Oh, 18.
18. Excellent. So our highest value is 18. So we are trying to find a half of the 18. Okay?
Oh.
Right. And not the 20. The 20 is just so we gave ourselves a little space with the graph. but our highest value is right up here. You see it?
Oh, okay.
So then, if I was to try to put a little um, line here, for instance, basically our data cuts off right here. So as you can see now, it's like I split the data in 4 equal parts, you see? So from each to each here, equal parts. So here is 4.5. If I put a next 4.5, I get what? 9.
Yeah.
If I add a next 4.5, I get what? 13.5. If I add a next 4.5, I'm going to get 18.
Yeah.
Make sense now?
Yeah.
Tasia, hit me with your question.
You explain it.
Okay, nice. Wonderful. Making sense?
Yes.
You understanding, right?
Can you repeat
Which one?
about the 4.5 thing?
Oh, I was saying that, remember the distance between here and here is 4.5, okay? And then from here to here is also 4.5.
Oh, okay. Never mind
And then yeah, so basically I split 18 into quarters, right? Cause all of these add up to 18. So this here is a 1/4, this is the next quarter, this is the next quarter, this is next quarter. Making sense?
Yeah.
Lovely. See that how we learn, you know? Sometimes you gotta ask questions to get a different perspective, you know? I tell anybody try to
Just so you're saying every 4.5 we got something.
we got a line, yeah, essentially. The first 4.5 in this case we got a lower quartile. And how I get a 4.5, remember the highest is like 18, right?
Yeah.
18 divided by 4 is 4.5. So then from here to here is 4.5, here to here 4.5. I keep doing 4.5s and drawing a line across, you see? Make sense? That makes it easier to understand that way?
Yeah.
Y'all got this, man. Y'all got this. Just gotta keep going through it. As I tell y'all, practice is an important thing when it comes to maths. You practice, you practice. Remember the first day we talk about when you have a baby who is 1 year old versus an adult who is 20 years old. It comes from the experience. Yeah. So the more you practice, the better you get, the more mature you get at what you're doing, and then you grow your confidence in understanding what's happening. It's a lot of repetition. When they ask you certain questions, they're just trying to find ways of manipulating how they could ask you something. They could change the numbers, but you just gotta remember the process. So maths usually follows the process of going forward and then you knowing how to get back to where you was. Okay, so you follow a logical step and then you could do the reverse. How you would work out the interquartile range?
5 from 17.
X. Good. So then you get 6.5. So how do I do the semi-interquartile range now?
Just divided by 2. And you get 3.25 and 3 and 1/4.
All right. I telling me this too easy.
Don't get confused now.
All right. Okay, so I want y'all to let us look at this here again now. So we're going to go through how we build it. We'll build it together. And then once we build it together, I want y'all to try and find all of the things that we talk about. The upper quartile, the lower quartile, the interquartile range, semi-interquartile range. All right. So looking at this, we have the frequency for time spent doing homework. We have a set of time here. First thing we need to get is the cumulative frequency. All right, so starting us off, Arvin, what's the first number that's going to go on the cumulative frequency? What's going to go here?
6.
6. Jose, let me see if you redeem yourself now. What's next?
16.
16. Nice. Tasia, what's next? 25. Nice. Clayton, what's next? 30. Excellent. You got it? So what's the next thing we trying to find now? Clayton, what are we trying to find next? Let me see if you can help me. All right, we're trying to find a boundary. So the first boundary we got to look at first would be what?
The lower boundary?
The lower one, which is 49.
49.5.
Excellent, guys. Yeah, you're cooking. All right, so the next one. What's the next one? 59.5. Who would 49.5 match with?
0.
Excellent. 0. And 59.5 is going to match with who?
6.
Lovely. Then 69.5 is going to match with who?
16.
Nice. Then 79.5 with who?
25.
25. Then 89.5 matches with
30.
30. So when we actually doing this and splitting the graph, we know what number we have to use. Got to use 30. You remember last time we used 18? So with this one, we're going to use 30. All right. So this is what we got here now. So we start off from here, go straight to here. So I want y'all to sketch this, and then I want you to find the quartiles on the chart. So the upper quartile, the lower quartile, throw in one there and do the median as well too. And then after, we'll go through that. Once you got that, we will try to calculate the interquartile range and the semi-interquartile range. So use the graph here to try and figure out what's going on here now. Yeah, when you divide it by 4, it will give you like the quarters. So how much each to put, what you need to put together to get a quarter. So your first quarter gonna be what you get when you divide by 4. Then when you add the next one again, you get a median. You follow me there?
I think so.
So in the first one we had, right, it was 18. When we divide 18 by 4, what we got?
4.5.
4.5. So then 4.5 would be our way we would we had find a quarter for that first one. And then if you add 4.5 to 4.5, you get what?
9.
9. And that 9 gave us our what?
Median.
Our median. Then we add a next 4.5 to get that the next one, and that other 4.5 to that 9 gave us 13.5, which helped us to find what? The who? The upper quartile. All right. You follow that?
Yes.
So in this case, if we want to do that method, we figure out, okay, when I divide this by 4, what do I get? And then I do each phase piece by piece until I find all of them. Okay? Or you could just find a median. When you find a median, you bust that in half and then bust the next upper half and you got it. Anybody get anything yet? Still working on it? Uh-huh. After you hit this blue line here, so as soon you hit that line,
Yeah.
Oh.
you come down. As soon you hit it, boom, down.
So what I was
What I did here, so what I have here now is a median. Okay? So we say 30 was a top cumulative frequency, the last value. So when I divide that by 2, I get 15. So here is 15. So that represents a median. I come straight here, then I come down. So the 59, I know each of these is 10, and the difference between here is 10. So 59.5, 60.5, 61.5, 62.5, 63.5, 64.5, 65.5, 66.5, 67.5, 68.5. Now, if this is 15 here, this was basically 15. What is the middle of these two? 7.5.
So, I ask another question.
Go ahead. You go for 7.5, then you come across, then come down to get a lower quartile. But if I go up 7.5, I can get a median. And if I go up 7.5 again, I can get a what?
The upper quarter.
Exactly.
That one had to do.
Nice. You got it? So that's 7.5. We come over here, so we say each of these was 1. So 59.5, 60.5. This here, I would say this is about 61. Does that make sense? Yeah, I'll follow this. Obviously, when you do it on your graph, it's not going to be as accurate because you probably just sketching it, and not using rulers and them kind of stuff. So obviously, it's going to give you a little, different answer. So I want y'all to have this one and then try the quartile, the upper quartile. So now that we went through it again, it makes sense. Y'all better understanding what's going on now. Say again.
getting it now, but we're just confusing having everything
Yeah, that what does make it a little challenging when you got to put all skills together. Don't worry. After you guys do this, we can break to probability. So I can give you a little ease on when it comes to that part, but you can see the other part of how to do this. But as I say, when we got to put all of these together, that is where the practice comes in. You see what I'm saying? So you see it over and over. You keep doing the routine steps, and it's gonna just get easier. When you see it for the first time with everything together, it's like, whoa, whoa, what's going on here? All right, so y'all got upper quartile. Where we would draw the upper quartile from? 22.5. Everybody agree? Then once we draw the 22.5, what do we do now? Why did I stop here? Are you supposed to stop here or should I continue? Right, we're supposed to stop there. Then what do we do next?
Draw a line down.
Drop the line.
Exactly. So then now, once I read this value, it would roughly give me what that is. So this is 69.5. Okay, so we got 70.5, 71.5, 72.5, 73.5, 74.5, 75.5, 76.5. So here's 76.5. So that's my upper quartile. Does that make sense how we did that? No looking back at it? All right. So the question is, can you work out the interquartile range and then the semi-interquartile range? Let's work it out. Lovely. Everybody else got it?
Yeah.
Lovely. So what is the interquartile range? 15.5. Josiah, what's the semi-interquartile range?
7.75.
7.75. Lovely. Everybody agree? All right. So if we did it for this, it would be the same concept as well too, right? But once they give it to you in these values here, what we do is notice how these numbers are overlapping. So you see how we have a 60 here and a 60 here, and then we have a 70 here and a 70 here. This is actually showing us the actual boundaries. So in this case, this represents the boundary. So 60 represents the boundary, and in this case 70 represents the boundary, and 80 represents the boundary once you see that overlapping. Does that make sense? Good. Now the frequency, the cumulative frequency, we do it the same way. So we add the numbers. So 9 plus 18 is 27. 27 plus 12 is 39. 39 plus 11 is 50. Okay. So then 50 would be our lower class boundary, which will end up matching to what number?
Again?
The 50. What number will the 50 match to in terms of cumulative frequency? What do we usually make that lower boundary match to?
0.
0. The next boundary is going to be what? 60. Who will the 60 match to? The 9. Good. So in this case, you see how we had an overlap. That is why this is the boundary now. Okay. So this comes in every now and again. You might see this is a recent thing that they've been doing as well too. So for the next one, this one would be what? What would come here? 70. Then what? Then nice. So then we match those values. We draw the graph, right? So if we have to find the quartiles now, okay, what do you think we're going to match them to? Where would the median one go? Say again? What's the highest value in the cumulative chart in terms of the cumulative frequency?
Oh, 50.
50. So where would the median be? 25. 25. Okay, why? Because half of 50 is what? Good. So then roughly that's our median, about 69 I would say, right? Now, where would the lower quartile be? If this is 25, the overall goes to 50, where do you think the lower quartile would be? How you get 12.5? Good, so that's the middle of that part. So then we know that that's 12.5. Or if you wanted to divide 50 by 4, you would get 12.5. All right? So the next step we do, Kaelan, what do we do from here? What do we do from here? Remember, once we hit this line, what do we do? What did we do when we was up here? We go straight down, okay? And then we try to read that number. So we get 62.5. All right, so Kaelan, where does the next number go? we want to find the upper quartile. So we said this first part, the middle was 25. The quartile here was 12.5. We start from 12.5, come across. What would it be for the upper quartile? What number would we hit to come across on? 37.5. Excellent. So we go on 37.5, come across, and then we come down. Okay? Then we come down. Now, once we come down now, this is going to be our upper quartile. So you remember that now, Kaelan? We have to come across and go down? Good. So then now, once we read its values, so 75, 76, 77, 78, 79, which is our upper quartile. Does that make sense? All right. So what do we do now, Clayton? How do we find the interquartile range, Clayton? 79 take away 62.5. Make sense, Tasia? And then after that, if we want to find the semi-interquartile range, what do we do? Divide the answer by 2. Excellent. And that's our answer here, 8.25. All right, does that make sense? All right, good.